This meeting
Okay.
is being recorded.
Okay. EKS in AWS and GKE in um, Google GCP. Okay. Similar concepts. Okay. They all depend upon Kubernetes. And today's class is mostly focusing on how to create pods, what are replica sets, and what are this deployments and what are services. These four things.
Yeah.
Basically, let me share the screen now and let me go through the presentation. This presentation will be very fast because you both already know. Okay. So you all know the difference between a virtual machine and Docker container. Okay, or containers. The virtual machine has guest OS in it. Okay, but your Docker containers don't have any guest OS. Okay, they depend. They only have applications. Okay, like Node.js, React, PHP, like that. And here you have the guest OS plus your application in virtual machines. Okay, so that is to take note in this. Okay, Docker containers and I mean containers and virtual machines. What is the difference? Okay, so these virtual machines actually are called monolithic. The applications in virtual machines are called monolithic. Exam point of view, what is monolithic and what is microservice? Okay, microservice containers. Okay, and monolithic is your virtual machines. Now, container, okay, is a standard unit of software that packages of code and all its dependencies. Okay, so that application runs quickly and reliably from one computing environment to another. That means you develop in your desktop, you can run it anywhere in the world, any Linux system, any say Windows system, wherever you take it, it will run. Okay, it will run, and with the same same configuration, same setup, it will run. You don't need to do any other setup. A Docker container image is a lightweight, standalone executable package of software that includes everything need to run an application code. Okay, like your Node.js application. So it will contain very small software. Okay, on top of that, your application will be installed. It is very lightweight. Your Linux system is at least, okay, the OS itself is at least 5 GB, 10 GB, 10 GB. Okay, now, but these containers are only 125 MB like that. Okay, and it also has your application code, so small, only 125 MB. Okay.
Okay.
Now, Docker container advantage. What are the advantages? Okay, I already have given this to you all. Okay, efficient use of system resources. I already said only 125 MB it uses. Okay, and if it needs only say zero point 0.1 CPU, okay, out of 10% CPU, it will use only 10% CPU. And if it needs only say 20 MB memory, it will use only 20 MB memory. So it's less. The system resources are efficiently used. Portability. I already said you develop in your system, your say in your desktop, and you can take it anywhere and run it anywhere in any hardware, in any software platform, whether Windows, Linux, no problem, or Ubuntu or whatever, CentOS, RHEL, OEL, no problem. Okay, it will run anywhere. Okay, speed. Containers deploy rapidly and can be quickly patched. That means containers they run very quickly because they don't have underlying OS. Okay, OS takes time to reboot, start up. Enhanced development cycle, okay, can be scaled and updated quickly and efficiently. See, if when you do auto scaling in AWS and manage instance group in GCP, okay, they take time to start up, right? You have to wait for the instances to come up, okay. But here, no. So use cases, microservices, I already said, containers are used for microservices. Actually, each one microservice equals to one container, in fact. Okay. So they are decomposing monolithic applications. Okay. Lift and shift or refactor existing application into cloud architectures. So if you want to do lift and shift of your application, monolithic application, Docker containerization is a better option. Now, this is the infrastructure. Okay, this is the architecture of your Kubernetes. Okay, this is very important from exam point of view, especially for GCP. Okay, and even EKS. You have the controllers. Okay, you have the scheduler. Okay, this is your master node. Okay, master node has controllers, scheduler, API server. Okay, and you got each CD. These 4 components, very important. Okay, so what these 4 components do, okay, is controllers. Okay, controllers manage the controllers. Okay, that we define. So what are controllers? I'll come back to you all. Scheduler. Okay, what scheduler does is, okay, it will create the pod. Okay, container you want. Currently, think of container. In the worker nodes are nothing. They just host your pods. Okay, pod are actually containers. So now what happens? You got 2 worker nodes. They are called worker nodes. Worker nodes are used for hosting your pods. Okay, and master node, okay, is there to check the health of these worker nodes and the pods created on them. Okay, so the components of master node, okay, API server. Okay, this component is the one you work with. Okay, you create a pod to give the command to create a pod. API server will take the command and work with the controllers and scheduler. Okay, to provision your pod. Where to provision, it will do that. API server. See, and this API server will talk with the worker node to place your pod. Okay, so this is simple architecture. In your master node, you got controller, scheduler, and API server, and a database called etcd. This is like MongoDB. Okay, like your file store. Okay, and in AWS it is called DynamoDB. It is like DynamoDB. Okay, key value pair. Now in your worker node, see, master node has 4 components, 4 components, and your actually that is one more cloud controller. Okay. Now in your worker node you have 1, 2, 3. 1, 2, 3. Not 3, 1, 2. You can say two parts. Kubelet. Okay. Kubelet is that part of your, say, worker node that communicates with the, say, your master node. Okay. So that means if the master node says, okay, create a pod, it will create the pod. Okay, whichever worker node, and they will reply back. Okay. Suppose you ask for how many pods are there, master node will send the request to the worker node through kubelet, and it will reply back. Okay, so API server and kubelet. Okay, these 2 are very important to remember where they exist. They will say like API server is present in master node, worker node. So where is it? In master node, API server. Okay, now there is something called network proxy. Okay, in kube proxy, actually it is kube proxy. Kubelet, kube proxy. In the worker node earlier, it's not in the master node. Okay. So worker node, this particular kube proxy communicates with the users. Okay. Suppose you say created an application and it is launched in your pod, and if the user accesses that particular website, okay, in your pod, okay, that is communicated through the kube proxy. Okay. So kube proxy, okay, helps to manage the network, okay, in the pods, okay, in the pods in your worker node. Okay, so kube proxy communicates with the users. Okay, so this is simple, say, information. Here actually what you call the same thing is here. You in Kubernetes, okay, you use the command kubectl. Some call it as kubectl. Okay, I call it kubectl. This is one command, Siva. Okay, this is one command. It communicates with the kube proxy, API server. Okay, and that this is in the master node. This is master node, and master node is also called control plane. Okay, be careful. Master node is also called control plane. Okay, and your worker nodes are also called simply node. Okay, you can simply call them node. Now, I told you there is something called Kube Cloud Manager, Kube Scheduler, Kube Controller Manager, Kube Cloud Manager. This Kube Cloud Manager, okay, helps to make communication between the on-premise Kubernetes as well as the node as well as in AWS or between AWS and GCP. Okay, so cloud manager is to help Kubernetes setups between different clouds, different cloud in providers. Okay, so now in our worker node, okay, in our worker node we have pods. Suppose I have one Nginx pod here, one Nginx pod here, one Nginx pod here. Okay, these pods are created by using kube scheduler. Okay.
Okay.
Now the kube scheduler via kube API server. Okay. So the kube scheduler, once it gets the request to create a pod, the control plane or the master node, it will send the information on the node, whichever it needs to implement, and it will tell it through the kubelet, please create this pod. Okay. It may be in this, Okay. So kube scheduler ensures that, okay, your pod is running and it is not stopped. Okay, if this is stopped, then it will automatically again start it. Okay, by not stop, I mean by some problem, by some thing, if this Nginx pod is down, it will recreate again. Okay, so all those how we do it is coming. And now, how does kubectl command flow? Okay, how does it flow? This is the user. You are the user. Okay, you say support kubectl get pods. This displays the number of the pods information in your kubectl Kubernetes. Now Kubernetes sends the information to kube API server by the HTTPS calls, API calls. Okay, so when you say kubectl, actually it is making a API call. You also should be knowing what is API. API is application programming
interface.
Yes. So through this API, okay, the request will be sent to the master node or the control plane, and the kube API to the kube API server. Then the kube API server will send again through the API response to the kubectl. Okay. So when you say kubectl get pods, and it shows you the list of the pods you have, okay, it is coming via the kube API server. Okay, it is actually going to the master node, not to the worker node. Okay. Now kubectl commands. Okay, you use kubectl is the command. Okay, and you tell your command what to do. Okay, what you want to do, you specify here like get. Okay, it can be described. It can be create. Okay, it can be exposed, and on what type of object you want. Okay, like pods, deployments. Okay, nodes. Okay, we'll be doing pods, deployment, and Replicasets and service today. Okay, and then you can give the name. Okay, pods, say XYZ pod name is XYZ. Then you can say you can give the flags here, what information you want. Okay, so this is simple structure of kubectl command. Here what we said, kubectl get pods. Okay, so this is the kubectl. This is what command you want to execute and on what type of objects, that is pods.
Okay.
The syntax, okay, still the kubectl get pods. Okay, what you want, this is pods. Okay, kubectl get my test app pod. This is a pod name. Okay, so it will give the, if you say kubectl get pods, it will show you all the pods. kubectl get pod my test app, it will show you only this particular app, this pod information. Okay, now kubectl get pod my test app minus o yaml. This is minus o equals to yaml is the flag you are giving. kubectl get pods minus o wide. We'll use this command in a while. Okay, this is flag, minus o wide is a flag. This one I don't need to tell, we are already aware of that. So let's see, each cd service. Okay, you need to know what are these services. When you install Kubernetes on a system, you are actually installing the following. Okay, API server, each cd service, kubelet, container runtime, controllers, and schedulers. Okay, So each CD is key store. Okay, it will store your information about the cluster. This is a database actually. Okay, and this should not be corrupted. If this is corrupted, you cannot get the or create the information about the cluster or the pods. So each CD is distributed reliable key value store. Key value store is a kind of database. Scheduler is responsible for distributing work on containers across multiple nodes. Okay, so scheduler, what it will do, it looks for newly created containers and assign them to the nodes. Okay, so what scheduler does, I told you here. Okay, the scheduler, okay, will create schedule or create pods on the worker node. Okay, scheduler. Okay, the controllers are the brain behind orchestration. Okay, so the controllers manage the controllers. Okay, so what are controllers? I'll show that to you. Okay, they are responsible for noticing and responding when nodes contains or endpoints goes down. So that means controllers will know. Okay, in a control. Okay, suppose in a replica set, suppose one of the pod is down, then controller will know it and it will immediately tell the scheduler to start a new container in that particular replica set. So what is replica set? We'll do practically. The container runtime, okay, is underlying software that is used to run containers. So container runtime will run the containers, okay, and kubelet is the agent that runs on each node in the cluster. When I say node here, Siva, what am I saying? What am I referring to? Worker node.
In the cluster,
yes.
We have a number of nodes.
Yes, worker node and master node. So simply node means your worker node. Simply node is worker node. Okay. So master node, when you want to say master node, you have to say master node. But for worker node, you can just say node. Okay. And that is another, that is control plane. Control plane is your master node. Okay. The agent is responsible for making sure that containers are running on the nodes as expected. Okay. So the kubelet agent, what it will ensure that the containers are running as expected in the nodes. Kube proxy, okay, it takes care of networking within Kubernetes. Okay, I told you, kube proxy will allow the users to communicate with the Kubernetes. Okay, whatever say, we'll see in a while. In Kubernetes, okay, any kind of object, okay, see what are the objects? The main object that we create is the pod. Okay, another object we create is the replica set. Another one is your deployment, and comes your service, and comes your daemon sets, and you still got stateful sets. Okay, so these things will come later, but today we'll be doing pod. Okay, so everything can be done in two ways. One is, okay, one of them is called your imperative way. Okay, imperative way is you directly say create a pod on the command line, kubectl create, okay, or run kubectl run, and it will start running the pod. Okay. Another one is you write the code in a YAML file, which is the correct way of doing. This is called declarative way. Imperative, declarative. Okay. So when you do in a declarative way, you write a definition file with YML or YAML extension. Okay, and both of you be very careful. YAML or YML are very this indent sensitive. It must be indented properly. Okay, and this YAML file, okay, the Kubernetes YAML file has some components which has to be defined. Most of them. Okay, the first one is API version. Second one is kind. What kind of, say, object you want? Pod, service, replica set, and deployment. Which one you want? Metadata is the part, okay, where you define your name of the object, okay, and you define labels. Labels are what? They are just, say, tags, okay, and this is very important. Spec. Spec is the specification of the pod you want to run. Okay, the pod you want to run, okay, that specification is here. Now containers, what is containers? Okay, this containers keyword, okay, tells you, okay, what are the containers you want to run in this pod. Okay, remember, normally one pod, one container, okay, but it can have multiple containers. Okay, let's say for example you want Nginx as well as MySQL running in the same pod, pod, not container.
Okay.
So don't confuse with container. Container is actually related to image. Container is image. Pod is running that particular image, okay, image as containers. Okay, so when you say containers, you say name and you give image and the image name here, and this image name can come from Docker Hub, or it can come from your AWS ECR. Okay, and in Google, I think it is called Google Artifacts now. Okay, artifacts. So it should come from there, from your if you use ECR or you use Google Artifacts, they are private to you. Okay, so you have to give your full path here. Okay, but if you just say Nginx, it is taken from the public Docker Hub. Okay, now see, kind can be your pod, service, replica set, or deployment, and version API version. For pod and service, you give V1, and for replica set and deployment, you give F/V1. Okay, and how you execute? You execute by saying kubectl create -f and definition file, YAML file. Okay, so we'll be doing that now. Okay, so we'll be creating replica sets, and we'll be creating service, and we'll be creating deployments. Okay, so let's get into the lab. Siva, okay, actually Novin already knows it. We can deploy Kubernetes in your GCP VM instance, okay, competitions VM instances, okay, but you'll have to select the one with 2 CPUs and at least 3 GB memory. Okay, so I think E2 small should be okay. Okay, and you choose CentOS or RHEL, don't choose other. Okay, and I'll send you the commands to install this your Minikube. Minikube actually will create a this Kubernetes environment for you. Okay, by using Docker. Okay, so you can execute most of the kubectl commands there. Okay, so I have done the same thing. Okay, let me wait here. My AWS cloud. Wait now. Let me log in. The 172.85, right? Oh, the IP has changed. Wait up. Not IP change. I give the wrong IP. So I'm connecting. This is the way in AWS. Okay, from Cloud Shell. In GCP also. In GCP, actually, you directly go to the shell. SSH. Correct, Shiva?
Yeah.
Okay.
Yes,
so here, yeah, this is how we go into the EC2 instance in Google Cloud, in AWS. Okay. Yeah. So now I already installed Minikube here. Okay. Which Minikube? Okay. See, I already installed, and which Docker. Okay. I already installed Docker also, and I believe Docker is already running. So I can say ES -EF grep Docker. Okay. See, Docker is already running here. Okay. So now I just need to run the Minikube. Okay. So I'll just say Minikube start. Okay. Actually, this has nothing to do. I've not started my Kubernetes. Now it will actually, this Minikube will create me one master and two, I believe, two node. Okay, two worker node Docker instances, which I can use for practicing my kubectl. Okay.
Okay.
Now I'll create a pod. I'll show you how to create a pod. The command is same everywhere, anywhere. Whether you use GKE, AWS, EKS, everywhere it's same. Or you create your normal Kubernetes say environment is same everywhere. So it's configured now. So I'll clear the screen. Now if I say okay kubectl, okay, create pods, okay. See, one pod is already running. Okay. See what happened. So this is done by what? Scheduler. Okay. The scheduler knows, okay, my HTTPD 01 pod was started and it went down when I shut down the system. Now, when I start the system and kubectl, your Kubernetes is running, okay, then it will see which were the instances that needs to be running and it will create that. Okay. Now, if you say kubectl, okay, to remove it, okay, it is kubectl delete, okay, delete and pods and the name of the pod. You can say pod or pods, no problem. The pod name is HTTPD 01, 01, okay. So it says it's deleted. So now if I use this get pods, there are no pods now. Okay. Yeah. Now I'll go to my folder Kubernetes. Here, okay, I have this YAML file already created. Okay. Now if I go into more, let me clear the screen. pod.yaml. Okay. Wait, sorry, more pod.yaml. So see, it's the same syntax. Okay. So in this syntax, this is API version is mandatory, kind is mandatory, metadata is mandatory, and your spec is mandatory. In metadata, you need to have name. Okay, so my pod name, okay, my pod name will be HTTPD 01. Okay, and these are labels that I'm giving. This label, okay, will be used to create a say service, okay, which will say create the suppose I want to expose this particular HTTPD server to the internet. Okay, that is not possible simply in this way because you have thousands of ports in the worker node, right? Thousands of HTTPD port, correct? Now those HTTPD, you know the default port, it is 80. Okay, now if there are 1,000 ports and all the ports use 80, how you will manage them? Which port to, when you say, okay, that your IP address colon 80, so how do you know which say port it is going to? Okay, that is done with the help of service, which we'll be doing. Okay, now, so I have put two labels, okay, here, to app and type. Now this information will be used in my say service letter. Now spec is it is required, and in spec you got containers. Okay, this is the your information required minus name. Okay, that minus name I have given HTTPD 01. Okay, and image. Okay, what image I want to use? I want to use HTTPD latest. Okay, now remember this is coming from where? Docker Hub. Okay, this particular image. Okay, so now to create your this pod, okay, you'll just say kubectl, okay, create, okay, minus f, name of your YAML file. So my YAML file is pod.yaml. So what this will do? This will create a pod called HTTPD 01. Okay, so let's see. See, it's saying pod HTTPD 01 created. Okay, now I can say kubectl pods. Okay, fine. Now, suppose I need to see this pod in a more. I want more information. Then I can say minus o, okay, space or minus o equals to y, or minus o equals to y. So it will show in a wide format. See, okay. Now here the IP address of that particular, say, your pod is this one. This is internal IP. Okay, it cannot be exposed to the. It is not exposed to the outside. How many minutes I have now? Oh, it's still 5 minutes. Okay, we'll finish this. We'll finish service. Now, in order to see if my HTTPD is running in this IP address, right? Now, this is the IP address of the pod. Now, this particular, say, IP address, I can say call HTTP. Then I can say 172.17.0.4. Okay, but it will not respond. Okay, the reason is, okay, see, failed to connect on port 80. Okay, because this port 80 of this particular HTTP 01, okay, I want it to be accessed through service. You need to access this through service. Okay, for that, I have created one that is called more srv.yaml. Okay, now here what happens is you got API service API version v1. Okay, for service and pod it is v1. Kind is service. Okay, metadata I have just given the name HTTPD01, and I say spec. Okay, and in spec I say selector. Okay, app HTTPD01 type HTTP frontend 01. This one I had given it here in my metadata labels. Okay.
Yeah.
So that means now when I create this service, okay, any Nginx, any pod that has this as the, say, labels, okay, and their port 80, okay, port 80, okay, will be exposed, okay, to the port 80 of the, say, a worker node, okay, of that particular worker node where it is located. So let's create that. Okay, create -f. Okay, kubectl. Sorry, kubectl. Create -f and the file name, right? srv.yaml. Correct.
Yeah.
Correct. So it will create the service. Sorry, it says already exists. So let me delete the service first. kubectl. It's always delete. Okay, and you can say SVC or you can say service. You can say SVC also. Service name is HTTPD01. Okay, now it created the service. So to check the service, you can just say kubectl get services or service, that is HTTPD01. Okay, see, now what is it showing? This particular HTTPD01, okay, is a service in the cluster. Okay, this cluster, okay, this is your cluster IP, okay, which has no external IP now, but it corresponds to this port, okay, 30527, okay, in your cluster, okay, this node port, this cluster, this port number, okay. If you go to this cluster, this port number, okay, okay, it will go to which one? Our HTTPD01 instance, okay. Let me just, if you say there is a way to get the Minikube, okay, service is HTTPD01 -- URL, okay. So you can get the URL here, okay. So this is the URL, see, okay. This is for testing purpose only. I'm showing it to you all. In real life, actually, it is done by the load balancer. Okay, I say paste here. See, the HTML tag has come here. That means our HTTPD. Now, what is the thing here? What is happening? Okay, kubectl get pods HTTPD01. Okay. Okay, kubectl get service services. Shiva, just see this one, okay?
Sure.
Now, what is happening here is, okay, in this particular, say, pod, okay,
Okay.
we have created this particular service, okay, that will listen on 30527 port of the worker node, okay, with this IP address, with this port number, will correspond to this port number, okay. So what it means is, when you say, okay, the worker node, okay, like this, call HTTP, okay, and you say your worker node here, XYZ is your worker node, colon 30527. Okay, I'm giving an example. When you say this, okay, what actually it is doing? It is going to the HTTP 01's port 80.